I want to introduce you one by one. And so first we have Erik Steen, and he is a professor in Erik Steen Jensen, and he is a professor in the Institution of Biosystems and Technology at the Swedish University for Agricultural Sciences, and he's chairing the Crop Systems Ecology group there. He is an agronomist and a soil scientist, and he also teaches about co-responsibility. He also teaches and is co-responsible for the SOU Master's Program in Agroecology. Okay, welcome. Next we have Katarina Hedlund, and she is a professor at the Department of Biology at Lund University, and she's also the Director of Studies in Environmental Science there. Her research looks at ecosystem services and how they can use their value in, how we can use their value in promoting the sustainable use of soils and agricultural biodiversity. We also have Rasmus here, Rasmus Einarsson, and he is a PhD student in the Division of Physical Resource Theory at Chalmers University of Technology in Sweden. And his research is looking at the systems perspective to nitrogen flows in the food system. And he's also looking at how structural parameters in agriculture may reshape nutrient flows and especially nitrogen pollution in the environment. And last but not least, we have Bergslid, and she has a comprehensive set of knowledge related to Norwegian agriculture from multiple perspectives. She is both a small-scale farmer and also a former agricultural manager and advisor at the Norwegian Center of Organic Farming and for two different small-scale farmers' unions. There are so many other things to say about you all, but I had to cut a little bit short. But you're going to tell us all the things that you know about your fields, but also in relation to this report. We have about 40 minutes to do this. And I want to start with you, Erik Steen. I know that you have a presentation, so I will also bring that up for you here. And your question, there we go, perfect. So your question is about, you bring a lot of agroecological experience to the table. And I would like for you to briefly explain to us, the audience, the principles of agroecology, and because I think that some people might not be familiar with agroecology. And then if you could provide your opinion about the report. So you have about 8 minutes.
Wow! I thought it was about 15 minutes, so I'll try to be fast. Thanks a lot to the organizers. It's a pleasure having the possibility actually to dive deeper into a very interesting study, which Johan and many other people did. I'll try to give my point of view, as often mentioned, from an agroecological perspective, and hopefully highlight some of the important things coming from this study, and maybe also say a few things what could be future research required to follow up further on what has been done so far. I just want to say, when Johan was presenting this, it was clear that we saw the SLU logo, and Johan is working in Uppsala, but I'm working in the very south, so you can see up there in the corner, just across Öresund, SLU have also a campus where I'm based for my research. So this study, in my opinion, comes very timely. We know that from several Nordic countries, NGOs have been lifting visions for having 100% conversion into organic farming. So having how should you say, more scientifically based evaluation of the scenarios for actually such complete conversion of agriculture into organic, I think is very important. So that's the first thing. I also read in a mail recently that there will be very shortly a meeting in Austria in the EU about Food and Human Health, which says that 60 million people in the EU actually suffers from diabetes, and 55% of the population in Europe has some obesity problem. So we need also to care about our diet, and this study links the two things, having more sustainable agriculture and also considering the diet. So when I had to say something of this, I first had to find out what is actually expected when someone works on sustainable diet. So I found this definition that comes from the FAO, the Food and Agriculture Organization of the UN, saying that when we are working with developing more sustainable diets, it should contain all these interesting elements. And when I look to some of these keywords, I really think that this work, this study, involves many of the things which are expected from them. Though the low impact of on the environment, food security, and other aspects, including also evaluating nutritional quality of the work. I forget to say also that in some Nordic countries there's a debate on how is it possible to have a greater national self-sufficiency in food, because it's not all countries like Denmark which is able to produce enough food for the population. For instance, in Sweden, it's about 50% of the food consumed in Sweden which is now produced in Sweden. So this is also additional debate, the self-sufficiency in food, which is essential. So after you asked what is agroecology, and I actually had a slide here because there's many perspectives of what is agroecology. So I don't want to give all the different views on how we can actually approach agroecology, but mention to you how do we see agroecology. For instance, in this 2-year master program we run in agroecology at my campus at SLU. We have two perspectives in agroecology. One perspective is how are we able to design future agricultural systems based on principles of ecology and considering the specific place where we are doing agriculture. So this is one key issue of the way we see agroecology. The other aspect is a food systems approach, that when we work in agroecology, the other aspect is that we need to consider the sustainability of the whole food system. I will show you another slide in a moment about what is the food system. But the important thing here is that when we are working in this food system perspective, we are working from production to the table where we are eating the food, and also considering recycling of food residues and waste back in agriculture. So this is the important part, these two elements of how we see agroecology. The food system is quite complex. I won't enter into detail about this, but if you have a food system perspective, you need to consider all the elements of the food system, in my opinion. It's not always possible because we don't have enough resources to study everything. So sometimes we need to limit to part of the food system. So of course here in this study, it's very much about farming. It's very much about the environmental impact and also about the food itself in terms of its quality and able to have a security for the Nordic population. But when you are in an agroecological perspective, the environmental, social, and economic aspects are incorporated in doing a study of the whole system. And yes, we are all aware that what was even said many years ago, food consumption and environmental change, food security, food sustainability are on a collision course. And that's why we need to have to do something to consider how we can develop more sustainable our food production and diets. So, in my opinion, This future Nordic Diet study is an important and valuable study for determining in a Nordic context the feasibility of upscaling organic farming for food self-sufficiency 2030 in the Nordic country. Yes, and it shows it's possible. It's feasible actually to have this vision of 100% organic food production for the Nordic people. And I think that's a very important message of this study. And of course, we have already heard Johan explain, so I will not give all the details about the result. Or what more was to say, what I think is important coming out of this. Also, here there's the evaluation of the environmental impact, especially in terms of climate change and on nutrient losses when we have an organic low meat diet. Which similarly is very important in a also policy discussion, having the basis for saying how can we actually transform our food system. And the last thing I want to mention here is that we also saw from what Johan presented that the diversification of our production systems is very important if we want to feed a Nordic population with organic. And I will probably skip a slide in a moment, so I don't say more about that because you have already included these aspects of diversification. And my final comment here about the good thing is that it's very important for developing policies about having more sustainable organic farming systems and diets, and give recommendation for what should we be doing in the future in terms of research and development. And you asked for principles of agriculture. One key principle, or maybe the key principle of agriculture, is actually diversification of systems. And I won't enter deeper into this, just mention that the requirement for what we have seen in this result is diversification, having more vegetables, having more grain vegetables, having more oil seeds in the system, and using the grass pastures in more different ways than only feeding animals. And you saw this with other colors from the presentation that Johan made, that we will have more or better distribution of more different crops in the system. And that's a key issue when you work with agriculture and development of agriculture system. Then finally, some comments for future work following up on what was done in this study. I think already in the report and what Johan presented here, they point to some limitation and weaknesses in the report and the study. And when I read it, I think I can just highlight a few things, which maybe we will hear later on from Johan in the discussion, because I don't really understand why we have a very good development of the current consumption diet in this work, but there's no actual calculation of the environmental impact of this diet which you have actually developed. Maybe it's on the way, there's some work which is being done right now, but I would like to ask you, or maybe this is some future work, that to have an actual comparison of the current consumption diet with the two scenario diets. Another aspect, I think, is that when we have an agricultural perspective, it's important to consider, as far as possible, the food system perspective, having the whole value cycle involved in such study. Of course, it's very much easy for me to say we just want to have more work, but when we are working with sustainable development, it's also essential that we consider the economic and the social aspects of the change we are trying to do. And I suggest that this is very important work to do, following up on this initial things done. We have got to focus on environmental issues. And finally, as also Johan mentioned at the very last, the feasibility very much depends on that we have enough nutrients in order to produce the crops in the system. And here, further analysis and study are required to find out if we want to change into 100% organic diet for Nordic citizens. We need to be sure that there will be enough nutrients to produce the crops we want. So thank you very much with a picture here from our campus just across Norsøk.
Thank you very much for keeping on time. So next up we have Katarina, and do you have a presentation?
Yes, it's on there.
It's on the computer. So let me just put it up.
It's that one, yeah.
Yeah?
Yeah.
Great. Well, so I had a question for you, and the question was about carbon storage, and you're an expert in carbon storage in agricultural systems. And so I asked you to make us fall in love with carbon storage, and then to kind of reflect on how it relates to the report. So I'll give the floor to you. You actually have about 10 minutes, because I gave Erik Steen 10 minutes.
All right, yeah. Thank you. Yeah, when I had the challenge to talk about how I can make you fall in love with soil carbon, I thought, this is the prettiest picture you can ever see. And that is starting with, I think, whenever you do agriculture or anything that you want to grow, you have to start with the roots of the things that are growing. And they are in a context which is very, very much dependent on what is there. And it's not just, the soil or where it is or the climate or whatever type of farming system you put on top of it, but this is the engine of everything that is growing. And I'm trying then to see, and in this engine there is lots of things living and making this engine to work. And here you see a variety of all the organisms, from bacteria on the right side, and the fungi, mycorrhizal fungi, having mycorrhiza and actually pouring nutrients from the soil into the crops. And then we have a number of animals that then will increase the rate of transfer of nutrients from the soil and already dead organic particles back to becoming nutrients to the plant. And if we can then sustain this engine to work very well for us, then we hardly need any nutrients added from the above. That's what happens in the natural systems. We have natural grasslands, we have forests and things, and this is this engine going on. But when we do agriculture, independent, whether it's organic or conventional or whatever type of agroecological system we're working in, it generally goes down into the roots and destroys this biological system. It breaks up the fungal pathways, it breaks up the mycorrhiza, and it depletes the possibilities for the crops to really take up the nutrients. And most of this is actually driven by the soil carbon, because I call that the currency of the soils for being able to produce the crops, because they are also dependent on carbohydrates, just as we are. We can't live without carbohydrates, as we heard you saying. We need that in our diet. And all these organisms also need the carbohydrates in their diet. And that comes then from the plants, bringing down the soil, the organic carbohydrates, both by residues, but mainly by the roots. And plants produce huge amounts of carbon that is pumped into the soil. And that carbon pool is almost never, ever accounted for in the modeling, as you showed. And then this makes the soils then to function. So the more, if you have a good healthy soil, you should have a good soil carbon content. And on the left side, you see a soil core where the carbon content is much higher than on the right side. It makes the, it makes the soil to absorb more water, store more water, be more efficient in nutrient handling and so on than on the other side. And this, when you have too little soil carbon, you will have effects like wind erosion, water erosion, and lose the upper soil organic carbon in the soils. And I just want you to reflect on this. So what does this mean? The whole report is concerning climate change, carbon emissions. How can we eat sustainable, not to have more carbon lost into the atmosphere? But if we think about the proportions of where the carbon is in the world, the ocean is the very, very largest part, and it's a fantastic absorbent of carbon dioxide. But soils have much, much more carbon together than everything that is growing on the planet, than that everything is in the atmosphere. So whatever we do with agriculture that is going to release carbon, that is much, much, much more potential than anything else. So keep this in mind. This is why soil carbon is important. We should not forget that. And I'm coming back to the report now. Or maybe I should stay here. Yeah. So you don't read while I'm speaking. Okay, so reflecting over the report, I think it's interesting to see where you try to take a large picture of trying to compare, what can we grow and what can we eat. I was a bit surprised that you only use the assumption of organic farming instead of maybe testing some more different. It could also be the current way of farming. There could be agroecological systems. Eco-intensification is another term that's become very popular over the years, kind of mixing the systems in much more reliable on the ecosystem services produced in the landscapes. So that's one of my reflections on this. And also in the report, when you discuss the impact of the cut of the systems of how much you can grow, in competition with food, feed, and fiber, I find that very interesting, because I think having the competition of land for food, feed, fiber, and also conservation of biodiversity, which is not anything I really saw in the report in that way. These are the 4 factors that are really important for keeping the agricultural landscapes really sustainable in the long term. And my final comment on the reporting is that when you show the figure on the carbon sequestration and how you deal with that, and most of these models rely on the input on the top of the surface, and they are underestimating what the plants grow. So if you have Lays, for example, as you say, they are very good in producing lots of carbon into the soil. And we have looked at a number of long-term experiments across the temperate zone in the world. And you can do this is an easy model. This is not modeling in the sophisticated way that you have done. And we looked at time series of different types of management that you could use. Some of them they are both used in organic or in conventional. That doesn't really matter. But you can see that in most of our farming system, we actually lose carbon. We have a net loss of carbon. And not to have a net loss of carbon, we need to have the cover of the soil covered all time across the year with cover crops, having the stubble left and so on, allowing maybe weeds or things during the winter. And if you want to add up with farm manure to compensate for that, you have to add something like 30 tons per year and hectare, which means tremendously effects on eutrophication on the landscape, which is not very good, and high production of nitrous oxides. And we also saw that lays are good if you have in one of the Swedish long-term experiments where you add, can I point with this? This one. This is a standardized kind of cow farm management where you have 1 year lay in 4 years crop rotation, and you add the farm manure, you take away the grass for hay, but you still have a loss of carbon. So to counteract that, you can see if you have 2 years of lay in a row where the roots can go larger and deeper and bigger and build up all these biological networks, then you can actually go plus. This is a biofuel plant. So I think when you to me, a message in working on these sustainable food production systems, you need to look at them disregarding whether there is a specific farming system. but look into the factors, how do we manage it? Because you can have intensive organic farming, you can have extensive conventional farming, eco-intensification. It doesn't really matter what we call them, it's what we do which matters. So, this was it, yeah.
Thank you very much. I can say I was a little bit biased that I was always in love with soil, but I think maybe you've made some other people fall in love with it as well. So
you can have my poster on the on the soil profile, or on the mites.
Rasmus, do you have it? You do not have a presentation. No, okay, so I'm just going to leave that beautiful picture of soil behind you, if that's okay.
Excellent.
And so I would really like for you to bring this systems perspective to nutrient flows into the conversation, because that's your expertise, and then kind of pair that up with the report and where that comes in. And you also have 10 minutes to do that.
Well, thank you very much, Erik. Hello, everyone. I'll just bring my notes and watch over here so I don't overrun my time. So now I'm all mesmerized also by the soil picture. I think this is a very valuable picture and a valuable talk you gave, and it ties into my work, which is on nutrient cycling in agri-ecosystems. And I try to study on the systems level how our decisions on in farming structure affect the nutrient flows in the system as a whole. But I would like to take one step back, because Afton started today, and also the report starts with the planetary boundaries, which I'm sure many of you have heard about. And skipping right to the core of my work, there is this proposal of a nitrogen planetary boundary, saying, okay, there's a maximum amount of new nitrogen that we can put into the Earth system every year, unless we're ready to accept some very dramatic types of damages or impacts on our lives. So it's being suggested that disturbance of the nitrogen cycle, or human disturbance of the nitrogen cycle, is one of those human influences on the Earth system that really have a potential to to have profound impacts on our quality of life on a very long time scale. So these are very, very serious ideas. And I tend to agree with the conclusion drawn in this work that we probably really have to reduce quite drastically, maybe by half or so, maybe more, the input of nitrogen into agri-ecosystems. In order to avoid certain types of damages that we find unacceptable. But that said, I also want to make a little critical comment, and my contention about the planetary boundary for nitrogen is that it is neither planetary nor a boundary, and I will explain what I mean by that. So first of all, it's not planetary in the sense that most of the environmental and health impacts we have from nitrogen pollution of the environment are local, regional things, maybe on a continental scale. But comparing, for example, with greenhouse gas emissions, where clearly we have a global budget because the atmosphere is well mixed. The nitrogen cycle is not well mixed on the planet, meaning that we can destroy our environment here, and it might still be quite good in terms of nitrogen pollution somewhere else in the world. And I mean, maybe I'm kicking in an open door here, but I think this is really crucial to remember. And the word planetary might sort of disguise that fact. And also, the word boundary I find problematic because it sort of suggests a threshold. Do not pass this line and you will be fine. which is also, I mean, to be honest, I find that the so-called planetary boundary for nitrogen, it's a rather arbitrary choice. Now, I'm not saying that it's wrong, the level that is chosen, but it's an arbitrary choice that goes back to what level of environmental degradation and what level of health impacts are we ready to accept. And there's no, for most of the nitrogen-related environmental impacts, there is no fixed limit which sort of is a clear science-based threshold. Yes. So further on, another complication when it comes to nitrogen, about talking about a planetary boundary, is that, well, nitrogen is not one compound. It's one element that appears in a lot of different chemical forms and has different effects in different ways, in different locations, at different times. And I think this is also necessary to consider when we talk about the planetary boundary. So these different chemical forms and locations and timings of nitrogen emissions into the environment, they have different effects. And let me just briefly review those, even though you might already know them all. And I made a list so as to not forget any one of them. We talked about eutrophication already, and the report says quite a bit about that, and also acidification of the environment. These are two clear impacts that you have also been able to quantify how they relate to your diets, and I find this really valuable. And then in the long run, both the eutrophication and acidification tend to change ecosystem functioning and affect biodiversity. And in the long run, this might have effects that are still not entirely known. But biodiversity, as you know, has to do with a lot of different things, and nitrogen is one of the things that influences the biodiversity and the ecosystem functioning. Then ammonia emissions into the environment, apart from eutrophicating and acidifying the environment, it also contributes to smog formation and particulate matter formation. So it refers to bad air quality. And this has enormous costs in terms of societal costs. Then there's nitrous oxide, which is a strong greenhouse gas being emitted from agriculture, but it's also a stratospheric ozone depletant, so it destroys ozone. And now that we got rid of the CFCs, the nitrous oxide tends to be one of the big things that are left there. Yes. So I'm almost out of time, but I want to now get to sort of where I think this report speaks, I think, to these issues. And I think it's really valuable that the report takes a full system perspective. So you're proposing two alternative futures as a whole, and we can see that they are internally consistent pictures of this might actually happen. And I think one problem in the type of work I do and a lot of the scientists do is we look at one part of the system. And when we look at one part of this system, we learn a lot about the processes there, and that's important and necessary. But there's a risk that we lose track of the bigger picture. So saying we can compare organic and conventional, a certain product, certain production system, but it might turn out that we cannot scale them without also scaling other processes. So as you show, the choice to have certain lay crops affects the possible land use for other things, and things are connected in complex ways. And I think your report does a very good job of showing how one choice affects the room for other choices. And I think it's very important to not only separate out separate small parts of the system. So thinking about all the other things that I talked about with the nitrogen cycling and all these different effects, having this type of systems perspective as you do sort of allows for, I think, a better treatment of what effects we actually have from nitrogen. Yes, so that's very good that we look at an alternative goal. Maybe if I have 1 more minute. Oh, excellent. Then I have plenty of time to make a final remark, or maybe I wouldn't say it's a criticism, but it's a suggestion of something we could work more on. And it has to do with the formulation of these scenarios. So an interesting thing is that the sufficiency scenario sort of had a lot of grass clover lays that were sort of left over. They couldn't be used for anything, or they didn't have an apparent, there was no apparent need for them in the model, apart from supplying nitrogen to other crops. So we grow legumes to fix nitrogen into the agriculture system. And that's all fine, but it looks a little bit silly when we're not using it then as animal feed. So then sort of the natural reaction to that is to formulate as we did in the efficiency scenario, is say, okay, let's scale up the livestock production a little bit, and we can actually make use of that. So I think that's a natural next step to take. I think another natural sort of alternative step to take had been to say, okay, maybe we could do away with some of those grass clover lays and instead use some mineral fertilizer. So this would be moving into what is today called the conventional agriculture. And I think it would be really interesting to compare it, to keep all the sufficiency scenario parameters, but just remove those lays that you didn't need to, that you didn't need if you had other nitrogen sources. And I think this would lead to another internally consistent picture, which would look quite different. So that could allow for a lot of more probably human food production with a very low level of livestock production. But it's qualitatively different. Now I know that this work was based on an explicit list of sort of normative judgments that were made at the outset of the project. And I think this is really commendable, and that's a very good starting point for the project to say, this is what we're starting from. And of course you started from the assumption it should be organic. And then that's a natural result. But then if you have me, for example, so thank you for this analysis.
Thank you so much. Did you have a presentation? Yeah, okay. So let's get this one up. Which one is it? This one. Okay. So I think those 3 interventions were really, really important to kind of set the scene for what Åsa will have to say, because she's coming really at it from a very practical side. She's a farmer, but she also advises farmers. So you have a very different perspective about this, and really love to hear from you about what you think of the report, but also where you're coming from.
Thank you, and thank you for inviting me, and thank you for a very interesting report and good speakers. So this is my farm back in Norway 70 years ago, and it looks basically the same today. So the question is it realistic? And I wish I could say yes, because this is our common farm. And as we know, there is no supply and there is no drain. So this is what we have, and we need to take care of it. But for me to say yes, just like that, I think I would need to see a miracle. But I do believe in miracles, so that's why I'm here today. I believe in miracles. Apparently, this is Norway, of course, and apparently Norway is going in the right direction. If you look at the main goal for Norwegian agriculture, which is that we want to increase the food production based on the Norwegian land resources, which is what this report is all about. And one reason is because we have extremely low self-sufficiency. It's historically low, less than 40%. So, and also we want to use the country, create values, and And yeah. And of course, with only 3% cultivated land, and we have huge grazing resources, as you have said in the report, in what we call utmarka. The ruminants are essential and brilliant, and this is very close to where me and Steen live, so if anyone wants to come and visit. But the goal and the reality are headed in the opposite direction. As you can see over here is the goal. We want to use the local resources, but there is lots of room there. Not so much manure, as you can see. And the reality is that the grain-based production of red meat is increasing. And as most of, I think most of you people know, that is not a sustainable way for the future. And the drawings are made of a friend of mine. Yeah. So why is this so? I think we have to take a look at the word effective. And it's probably one of the most said words in the Norwegian government these days. What is effective agriculture? Who defines it, and what is it? And what do we include, and what do we not include in the definition? And I'll tell you a story from my county, Møre og Romsdal, and it is probably representative for the whole country, and Sweden and Denmark and Finland and yeah, all the countries around. Last 40 years, 80% of the farmers are gone. And this is due to many things, but mostly because it's been an everlasting demand for increased efficiency in farming. Get big or get out. And of course, this has some effects on what we are talking about today. In my county, the last 16, 17 years, huge areas of agricultural land has been abandoned, and this is the agricultural land. And if you take the outfields, it's enormous resources not used. So it's 12% on 16 years. And for every farmer we lose, huge areas of land is left abandoned. And if you look what happens, you can see the numbers here. They represent milk production. So we have milk quotas, and you see the different. Is there a pointer here? Yeah, the red one. Yeah. Yeah. This is where I live, and Steen lives here somewhere, right? Yeah. And the numbers. Yeah. It's like here you can see that these two municipalities have increased their milk production with 3.8 million liters since 1999. And down here, they have decreased the production with 3.4 million liters. And this has an effect. If you look at the municipalities decreasing, 3.4 million liters of milk, that's a lot in two small municipalities. So they have lost 24% of the farmland. It's not more. It's not needed anymore because the animals are not there. And if you look on the other side, where they have increased the production with 3.8 million liters, you would think that the land use has increased, but it has not, because the land was already used, and you cannot move cultivated land. So the result is that the use of concentrates has increased by 64%. The number is not 100% correct, but I don't have time to explain it, so if anyone wonders, they can just ask me. And also, when you want to get big in Norway, here is a farm. This is these people I know. They have built here, it's probably 300 animals in this barn, and of course, it's not like Denmark. The land is not outside, so it's scattered around in the whole village. So you need to get hold of land all around the village, and it's lots of small pieces of land. So it's got some challenges when you need to get feed for the cows, or you need to get rid of the manure. And I've done some calculations, and on a farm like this, it's thousands of kilometers every year if you want to use the cow shit optimal, if you want to spread it on all the land you have. You have to drive and drive and drive and drive. So we have local and global, increasingly disconnection between production and resources, as you all know. And this, of course, is very known. And we take nutrients from here, and we don't take back the shit. Yeah. And also when you need to be efficient and build, it costs a lot of money. So you need to have a high production to pay your bills. And what is really interesting, if you dig into the Norwegian climate model, how we report, and if you look into the model, you will find that this is getting a green climate card. While grazing, extensive, organic, low yields, slow growth, grass-fed, all these things are getting a red climate card. And it is, you can almost lose your sleep thinking about this. Because it's totally crazy. So, how can we make the ideal and the real world head in the same direction? We know that we need to use the local resources. We want to use the local resources, but we are centralizing the production all over Europe and also in Norway. Yeah. And we want to be climate friendly, but we have some models pushing the production in another direction. And we want to be sustainable, but we also need to pay the bill. So we must be effective. And we need to close nutrient loops, but we have a system breaking the nutrient loops. So this is where the miracle comes in handy. And I'll just finish with this beautiful picture from the northern part of Norway. You can see Lofoten in the back. And some interesting numbers, because I am a ruminant lover, love cows. And if you take the Norwegian production of oil and gas from 2017, both inland and abroad, and you just burn it off, you will release 640 million tons of CO2. And that equals 195 million cows. In Norway, we have 220,000 cows. And we have a report from NIBIO, which is a Norwegian research institute, and they are saying that if you reduce the consumption of red meat with 40%, the overall reduction until 2050 will be 690,000 ton CO2. And this equals 1 promille of the annual emission from oil and gas. And when you ask Norwegian, how do you want to contribute to reduce global warming? Scaringly, many of them will say, I'll just I will reduce my intake of red meat. So, who gets to tell the story, and is the right story told? Thank you.
Thank you very much for that very animated and beautiful storytelling. I would love to invite the panel back up here. You can stand if you like, and we have half an hour if that works for you. And also, Johan, can you please come as well? Yeah? Great. So this is the point in time where we open the floor to everybody in the audience. So I'll just let you sit down first. All right, good. So we're gonna, yeah.
There's so many people who are raising. I think someone is needed.
Yeah, but okay, let's, guys, should we take a pause, or we have half an hour to go? Someone just told me to do that.
What?
We just keep going, right?
Yeah.
Okay. No. Okay, so we have half an hour before we have a break. I just had someone ask me if we could take a break, and no, we can't. We're going to keep going and have a longer break in half an hour. So this is your time to ask questions to the panel about the report, about their presentations. And please, when you ask a question, introduce yourself and where you're coming from. And also make sure you ask a real question and not something fluffy. I want direct questions that are to the point. So who has the first question? Oh, yes, you do. So I think it's on now.
Thank you. Steen from Norway, small-scale farmer. To you, well, first of all, it was a pleasure and I'm really interested to take part in this project. And very happy that it took the more agroecological direction, because that was not really the start. The efficiency scenario, there we have the same amount of milk, but we have a very strong reduction of meat. My cows and goats, they are producing both milk and meat. Does it mean that the reduction of meat is based on pork and poultry? And can you explain why in the national guidelines for healthy food, in Norway at least, by the government, it says that we should eat more pork and poultry, and not so much red meat?
Thank you for your question. So we've got 2 microphones roaming around, but no problem.
Yeah, thank you, Steen. First off, with the dairy meat production, like in these scenarios, we assumed only dairy production systems producing both meat and dairy, while our current consumption is based on meat from those systems, but also meat from purely beef producing systems, where and also red meat that is imported to the region. So the production, the reduction in meat is, as you mentioned, mainly from the monogastric animals, but there is also a reduction in red meat or beef due to our scenarios not including cattle just producing beef. And for the nutritional guidelines regarding red meat, I'm not an expert at all. So I can't really comment on that.
Okay, did anyone feel like they could also give a comment to that? No? Okay, so we have a question in the back. So I'll run over here. Oh, there's some cords in the way. I'll pass it to you.
Hi.
Anna.
Okay, hi. My name is Anna Rickert, and I work at WWF in Sweden. And I would like to raise a point about the carbon storage in the soil. And this is addressed to Johan and to Katarina. This is something that we're quite interested in. And you lifted some points around the 2 different scenarios, but you also, Johan, made a conclusion that it was not really a major impact that you could draw from this study. On the other hand, you, Katarina, showed that, for example, adding farmyard manure or plowing in crop residues, it would really depend upon the amount of residues or straw or farmyard manure that you put into the soil. So I would really like for both of you to comment on the potential of carbon storage in soil, and also ask you on why you didn't think, why this didn't come out as a big thing in your report.
Right. Thank you for the question. You can both have a mic.
So we can have a fight. Okay, maybe you can refer to the report first.
So for the soil carbon modeling in the report, we used a model that is developed at SLU, which is it's sort of parameterized from these long-term field experiments where they grow different types of crops in different systems, and they looked at how the soil carbon developed in these and tried to fit a model to that. And this is the model that we used, and it's driven by the input of carbon. So and the input is calculated from the yield of the crops, which gives us how much root we get and how much above ground biomass we get, and we also include how much manure we put on and how much carbon we basically put on the soil, including the roots. But this model does not it is calibrated to a conventional cropping system, and it doesn't include things as increased allocation of carbon towards roots in organic systems and things like that. So it's mainly driven by the yield. So that's why we get and also the type of crop, where grass crops sequester more.
Yeah, and I can also say all the data I show is based on the same experiment as their models, but it depends on how you do your models. and we have not done any modeling. When we have calculated how much carbon is left, it's just the rate of change. So this is what is measured. So this is kind of the net effect of it. And I think what struck us when we did this was that you need if you put straw back and you want in a crop system, when you grow wheat and things, then you need to put twice as much straw as you can grow from one field to break even, and that is not sustainable. So, but this is just as you say, the models that they use they are underestimating the effect of the carbon to the roots and the carbon that the roots pump out into the soil. So I think this is the missing link. And that will be much, much higher when you have either perennial crops or you have ley and the rotation and so on. So whether we take away some of the, not put back the straw or take away the ley, it does not matter that much. It's more how we treat the roots in the soil which matters, is the conclusion.
Did you have something to add as well?
Yes. One additional comment to what you mentioned, Katarina, is also that we often talked about carbon in the soil and soil organic matter. But soil organic matter is not only carbon, it is also nitrogen. So when we want to store more carbon in the soil, we also need nitrogen, because soil organic matter is both nitrogen and carbon and other nutrients. So that would impose, when we want to increase very much the carbon, the requirement for having more nitrogen also loaded in the soil, and need for more nitrogen ending up in the organic matter pool.
You also had something to add to that.
Thanks. I would just like to contribute a small complication also to the discussion on carbon sequestration in agriculture. So I'm not deeply into this topic, but one thing that's pretty clear even to me is that a certain management regime, let's say you have a lot of ley or you have less ley or whatever cropping system you have, it tends to, in the long run, equilibrate at some certain level of carbon storage in the soil. So that means we cannot really directly compare that. I mean, that means if we change the cropping system, there will be a change over time, but then it will stabilize, so it won't go on forever. Whereas other emissions connected to nitrogen cycling or methane from ruminant animals happen each year, forever essentially. So it's not straightforward to compare that one-time change with the continual emissions of other processes.
So, Katarina, you wanted to say something in relation to that, and then we'll move to the next question. So go ahead.
There is if you see that there is a general assumption there is some kind of chemical equilibrium reaching, which I think is just why is carbon disappearing from the soils? That's because it can be decomposed by the organism, and so it's an exponential decrease. You see, like a curve, like you have radioactive fallout. It will halve every year or something, but it will flatten, or you can reach, maybe it's saturated. You can't feed more carbon physically and biologically into the soil. And that is more like the soil organic matter will be hidden in the particles in the soil, so the organisms can't get them. That's why it's still in there. So there's no mysterious equilibrium more than it's just out of reach or it's full. That's my simple answer.
Thank you very much. So, I just want to ask a question. Are you just holding your phone? Oh, okay. I thought you had a question for Lund. Okay, so it's for you now.
Hi, my name is Annalisa Winther, and I'd like to first say thank you guys for your research and dedication and for organizing this and informing us about the report. I think it's super interesting. I am working with a variety of impact investors whose mandate it is to invest in a better, more sustainable future, very much like what we're talking about today. So from a business angle, looking more into the research side, and I'd like to extend this to anybody in the room who might have an opinion as well, I'd like to hear what opportunities you guys see or initiatives that you'd like to see more investment go towards in order to make this possible. Because we need to change the way that things are being done in the world and also the way that business is being conducted. So I'm curious to hear what the panel has to say.
Great question. Thank you very much. Who wants to take a stab at this question? Yeah?
We've been working in valuing the ecosystem services and also valuing the carbon into the agriculture to see, you know, how much, because the farmers today are very sensitive to what they pay for. So most of the farmers in the Nordic countries have almost stopped plowing as they did maybe 20 years ago. They do more harrowing, low tillage situations, and the main driver for this is not environmental reasons, but it's because they don't have to pay so much for the diesel. And that goes straight into the manufacturers of all the machines, all the machinery in the agriculture. So I think if we as researchers can show the influence of the values of what we try to promote to the farmers and to the, you know, how to produce these things in a friendly way that would save input and maybe not increase the output, but anyway increase the profit. Because an increased profit doesn't always mean that you have to have a higher production. It can also mean that you have lower costs of your inputs. And I think if we can align with the economists in a way and extend to that, there will be lots of business opportunities and to develop small companies for how you can farm your soils, how you can be efficient, but anyway environmentally friendly with less input. Yeah. So.
I think you had a comment?
Yes, to the question here, how to actually support such development which have been put into the scenarios. In my opinion, the essential thing is to consider how can we make possible that young people is entering into the area of organic farming. And we saw Rose presenting here that many farmers are closed and cut down. So to me, if you are able to work with people having interest in investing, I think the way is to say how can we have new forms of owning organic farming systems, so that people wanting to invest in farms in a new way, where it's not the people there is dependent on having to take big loans and running such thing. That would be a very important factor for the future, developing more organic farming food production.
Great. Anyone else? Yeah? Okay. And did anyone in the audience have a response to that question? It was also projected at it. So this is a response to the question? You had a response to the question? Okay. Can you help me? Thank you.
Hi, my name is Kasper. I'm a chaos pilot and a small farmer. I run a project where we're trying to finance small farms because I think, so in that sense, I think it's really interesting. And my point of that is that I think economy will change, and I think that investors will look at investments different. A short note, if anyone here, a lot of Norwegians, you know, Arne Næss's approach, I think, to values in nature. And I think that we are going to go back to that, just a bit like balancing the farming, agriculture. I think we're also going to balance our economy. It's not an answer, but it's a opening for a new way to look at the opportunities. And I don't know if I can put a question also.
You have the mic.
Okay. What I think is really interesting is that what the report says is that Norway cannot feed the whole country in in small farming, as I understood. But Rose, you also said that showed how the big farming has closed down a lot of fields and closed down a lot of land that would be, I think, ideal for this. What is your perspective on that? Or do you have any thoughts on if it could be possible, if we approach it maybe even more idealistic?
Thank you.
Yeah, as you say, we looked at the current arable land in Norway that is currently used. So the potential to increase the amount of arable land in Norway, I'm not sure. You are probably better at answering this. And then I can.
Yeah, I know that we can more than double the amount of animals we have in the outfields, and we have approximately, I think maybe 500,000 decars out abandoned since 2000 in Norway. So if you probably used the numbers that are in production today, I guess. So
From the arable land.
yeah. So we have more land, but the problem is that time is short because it's nature is taking it back, and also the outfield it has very high quality, but if you don't use it, you lose it. So, and we have this scientist. He's been around the whole Norway, and it's starting to haste. Yeah, because very, very, very high quality outfield is degenerating, or we lose the quality when we don't use it. And one of the biggest problem is that we are getting short of farmers, actually, to do the job. We need hands. We need farmers. And in Norway, that's like swearing in the church.
Can I do a quick follow-up remark? What we also saw, because we included the outfield areas in the model, but what we saw was that we couldn't have ruminants grassing all of them in the model because then the arable area that would be needed to grow winter feed for these ruminants would start competing with grain production that could be used for human food. And since animals always involve some sort of loss of resources converting feed into food, we start to produce human food less efficiently when we increase. So that's
great. Okay, so we're going to move to the next question. Please stand up and introduce yourself. And then we have Reiger, I saw you, and then you and you and you.
Hello, so my name is Lisa Hägglind, and I'm from the Agri-Food Economics Center at SLU, and working with research on environmental economics and agricultural economics. So my question is a bit directed towards you, Johan, but also Erik, coming back to the perspectives of the political sphere and also the economic part of this. So what I wonder is mostly, okay, this is feasible scenarios, but what are the economic costs and who is going to bear them? Is this going to imply increased prices for consumers or producers, and where are they coming? Or where are the prices ending up? And also, what political initiatives would you like to see within maybe the European agricultural political sphere and within Sweden and the Nordics? Thank you.
So maybe I'll just start a bit quick. I'm very bad at economics, so like what we've been doing here is maybe should be seen as sort of the biophysical options sphere. Sort of like this would be feasible, but within this, it's very much policy and economics involved. And maybe with that, I can leave it to Erik to follow up.
I'm not an economist, or I'm not into politics, but in my opinion, I think it's essential that all of us in the Nordic country and globally realize that food is too cheap for us as consumers. We need to consider that we are all willing to invest more in having more sustainably produced food, in my opinion. And another aspect in this context is that I think it's essential also that we have policies that a larger fraction of the price we pay as consumer actually will go to the producer. Because when we have developing value cycles where we have many entrepreneurs in between the producer and the actual consumer, when a large fraction of this price is actually generated between the producer and the consumer, I think it's making things more and more difficult for the farmer. So that's two important issues, I think, in terms of policy related to the economics.
Can I just add something to that and say that Danes, I don't know the rest of the Nordic countries, but Danes use 11% of their income on food purchasing. So it's extremely low, especially in the OECD region. So just to kind of complement that. I think you had a question.
Yep. My name is Rikke Pape Thompson, and I think I'll put on the cap being a plant ecologist. And this question might be a little bit old school, but I think still relevant for the debate. I know it's a Nordic exercise, but Erik, focusing on Denmark, having a wish, raising the food produced in an ecological way, where does it leave, because we are highly cultivated in Denmark, I think the land is. At least. Where does that leave room for nature or not so highly cultivated areas of land in Denmark? And also, could you elaborate a little bit on the manure issue? Isn't it true that we can't actually feed our ecological plants with enough ecological shit in Denmark at least? And how do we solve that problem?
Okay, thank you very much.
Yeah, I think on this question it's important to say that, I mean, I think except Norway, but the rest of us in Europe have the cap to, as one way of incentives and regulations to fulfill during farming. And all these regulations are on a very, very low level. So you can have very, very high stocking rates in some countries, like in Ireland. So they have huge eutrophication problems. excess of manure in some places and too little manure in other places. So this is something we can work on both from a scientific side, from a policy side, and from a political side, to make sure that the minimum levels of the CAP requirements, both on the legal instruments and on the more environmental fronts, can be, up and higher and across Europe.
Right, thank you. You had the microphone in your hand.
Does it work? Yeah. Hi, I'm my name is Erik. I have a question for Katarina Hedlund. I agree with I appreciate your talk about those soil carbon storage. I just want to say that when we let the grass growing in abandoned area, most of the time the soil organic matter is actually improving because there is no more plowing or no more harvesting. So I think the abandoned lands might be actually in a good shape because they've not been plowed and grazed for a long time. But my question is, yes, the farmers have stopped plowing in Europe, generally speaking, because of high cost of diesel. It's extremely expensive to plow, especially to plow deep. But I have a question. When we stop plowing deeper, the soil often gets more and more compacted, and I'm pretty sure there's a lot of carbon and minerals and nutrients in the lower layers of the soil that are actually blocked in a way that cannot be available it's difficult for the roots of the plant to reach these minerals. My question is that why are we not supporting farmers by helping them to sow cover crops, like by financing these cover crops, or helping them also to do more strip grazing with the cows, because they are grazing often too much the grass, and the grass roots cannot regrow deeper. So, and often also insist the small on how can we help the customers also to actually differentiate a grass-fed animal from a corn-fed animal, because as a consumer it's often very difficult to know how much grain animals get. But yes, my question, Katarina, again, is how to help farmers to sow cover crops and do more strip grazing.
You had a first argument saying that when you plow less, you have more compacted soil, and that is not true. So this is a general assumption. If you leave it without anything growing, yeah, but that's not generally allowed. So in lots of countries, it depends on your country levels of the CAP. So. Yeah, and there's been. This is again to CAP. We can influence the CAP to set subsidies to farmers to have cover crops. We can also show them how much they will earn in their own business model if they increase the soil organic carbon. So this is what that was my soil picture. You said the soil natural capital. It was the soil natural capital. Here we have other natural capital, yeah, which is very valuable, maybe invaluable. But I think what we as researchers are trying to do is to show the value of the natural capital and to include that into the business models of the farmers, to show that if they really care about increasing the biology living, then the roots can go down very deep in the soil if the earthworms are there. And if you have the carbon, it will give additional effects of having higher yields and lower nutrient input. And if we can show that you need to take 20 years to do this investment before you have a profit of it. And all you can do is, you say, you can have maybe strips of grass. Was that what you said?
No,
or
how you let the cows grazing if you let more time for the grass to regrow in
Yeah, yeah. I mean, you can show for all these different types of management that you do without cows or with cows or whatever, how much you will increase your natural capital value of your soils and of your farming business, and that is worth investing in it. That's one thing. Or you can have incentives from the government, like in the CAP. So.
You have the last word now before we head to lunch. So you are sitting with us and lunch.
I just want to highlight that this question about cover cropping is extremely important, and since cover cropping is an agroecological practice which is used in organic farming, many organic farmers have quite a lot of cover crops as compared to conventional farmers. And I'm happy to see when we look to farmers in Sweden that also conventional farmers are growing more and more cover crop. So a lot of things is happening in that area, which is very important.